Everyone, and welcome to this video, which is all about how we will analyze and use distance time graphs in the GCSE Coordinated Sciences course. So let's take the example you can see on the screen. We've got two lines, one blue, one red, and both of these are going to show very different motion, and we want to kind of see what we can tell about that motion from this graph. A couple of basic points about distance time graphs. When we're plotting them, we're going to put distance on the y-axis and then time on the x-axis. It's really important for our later analysis that we get this right. Now, as you can see, when we're looking at a distance time graph, we can tell many things. We could understand the journey that these two guys have taken. So, for example, blue has traveled a distance of 10 meters in 2 seconds, whereas red has taken 4 seconds to travel 8 meters. Now, we're going to try and go a little bit deeper than that and recognize, firstly, that if we've got some straight lines, then we've got objects which are traveling at constant speed. Now, generally, in GCSE, you'll have to deal with constant speeds, and we'll see at the end, you might have to do with some curves, and we'll talk about what those mean as well. So we could have constant speed with a straight line, and then we have a flat line which shows zero speed. Now, a key point which may be new, and this is where GCSE just jumps a little bit on top of our previous knowledge, is if we want to know the speed at any time, then what we can do is calculate the gradient of the line. So if I took the gradient of that blue line, I could tell the speed of the blue object, and if I took the gradient of the red line, I could tell the speed of the red line. Let's see some examples. So let's take the blue line. We're going to calculate the gradient of that line. Well, that is simply our rise over run. So we've got 10 over 2. Well, in this case, that higher speed comes at 10 over 2, which is 5 meters per second. And you notice here that is exactly equal to the gradient of the blue line. Rise over run, 10 over 2 is equal to 5. We could then take the example of the red line. Take a second just to think, what might the gradient of that line be, and how does that relate to its speed? I'm assuming you've had a little think and maybe had a try. The red line is a bit harder because we have to split it up into two parts. So from 0 to 4 seconds, the speed is, as we've said before, 8 meters in 4 seconds, which is 2 meters per second. That's a gradient of 2. Let's just check our rise over run. We've got 8 divided by 4, giving me 2. In the second section, we can see that this flat line. Now, hopefully from your math lessons, you're aware that a flat line has a gradient of 0, and so therefore the speed must also be 0 in this case. If we have a gradient of 0, our speed is 0, and therefore we say that the object is stationary. It means it is standing still, it is not moving. Okay, it is just keeping a fixed position. Feel free to take a second to digest that. We're just going to really quickly talk about what happens if lines get curved in a second. Okay, let's go for it. Curved lines. You won't need to deal too much with these in terms of your GCSE, and you very rarely have to do any calculations with these, so do not worry. However, it is worth looking at this in a bit of depth, and I've got another video that I can link to this one, which does look at curved distance time graphs, but that's really an advanced level concept. You may, however, be asked to look at the graphs like this, and you'll see there's a lot in your multiple choice. Here you can see that we've got a curved graph on the left hand side and a curve on the right. Left hand side is curving up and right hand side is curving down. Now, in terms of what the motion is, we say that the left hand side belongs to something which is accelerating, and the right hand side takes one which is decelerating. Have a second to think, why might that be the case? Why might we say that the left one is accelerating and the right one is decelerating? Well, hopefully you've got it. On the left hand side, we can see that we've got a gradient which is increasing, and that's what's causing that upwards curve. The gradient is increasing, and so therefore the object's speed is increasing, and therefore it is speeding up. So anytime you see a distance time graph with a curve up, it means the speed is going up. However, on the right hand side, we've clearly got a gradient which is decreasing. This means that the object's speed is decreasing and therefore it is slowing down. I'll just say again, just as we finish, you very, very, very rarely will have to do any kind of calculations with these, and so therefore you're really just looking at the qualitative behavior here. If we have straight lines, then that means we've got constant speed, graphs curving up, that means accelerating, higher speeds, and then graphs curving down, lower speeds, and thus decelerating. Okay, that's all for now. I hope that's helped a little bit with your distance time graphs. You now need to go off and do some calculations of gradient and speeds and see if you can put the theory into practice. If you have any questions, please feel free to let me know.